In this video, I want to show you some more examples of logarithmic differentiation. Y equals sine of x to the power of x. To find the derivative of this function, we cannot use power rule because the power and the base both are dependent to the variable x. So to find the derivative of this function, we use logarithmic differentiation technique. The first step is to take ln from both sides of the equation. If we take ln from the left and right side of this equation, we have ln of y equals ln of sine of x to the power of x. The reason that we take ln from both sides of the equation is that we can bring the power to the front of ln. So we can rewrite ln of sine of x to the power of x as ln of y equals x times ln of sine of x. Now we have to take derivative of both sides of this equation. For the right side of this equation, we need product rule. Let me remind you the product rule. Derivative of f times g equals f prime times g plus f times g prime. In this example, f is x and g is ln of sine of x. So derivative of the left side of this equation, ln of y, is 1 over y, y prime, or y prime over y. And derivative of the right side of the equation is derivative of x is 1 times ln of sine of x. So 1 times ln of sine of x plus f is x times derivative of ln of sine of x. Derivative of ln of sine of x is 1 over sine of x times derivative of inside. And derivative of inside sine of x is cosine of x. So we take derivative of left and right side of the equation. Let's simplify the right side of this equation. 1 times ln of sine of x is ln of sine of x plus x cosine of x times 1 is cosine of x over sine of x. If you remember from trigonometry, cosine of x over sine of x equals another trigonometry function. But you don't need to do this conversion. Anyway, cosine of x over sine of x is equal to cotan of x. So the right side of this equation can be rewritten as ln of sine of x plus x times cotan of x. Again, cosine goes in top. Cosine of x times 1 is cosine of x over sine. And we remember from trigonometry, cosine over sine is cotan of x. So we get to the last step of finding the derivative of this function. Y prime over y equals this expression, but we want y prime to be isolated. Y prime is derivative of the function. To get rid of this y in denominator, we multiply both sides of this equation by y. If we multiply left side by y and y cancel each other, only y prime remains here. And for the right side, we have y times x cotan of x plus ln of sine of x. And remember that y is sine of x to the power of x. So we can rewrite our final answer in the form of sine of x to the power of x, original function, times x cotan x plus ln of sine of x. Let's do another example. If y equals x to the power of ln of x, then find the value of y prime at e. It means that we have to take derivative of this function first. Y prime is derivative of this function, and then after we find derivative of this function, we have to plug in the value e. Okay, let's find derivative of this function. To find derivative of this function, we need logarithmic differentiation technique. As the first step, we take ln from both sides of the equation. Ln from left side and ln from right side of the equation. The reason that we take ln, again, is that to bring the power to the front of ln. The power of x here is ln of x. We bring this power to the front of ln. So it becomes ln of x goes to the front times ln of x. So we can write it as ln of x times ln of x. Now here, you have two choices. You can do it in two methods to find the derivative of this expression. You can use product rule because between ln of x and ln of x is multiplication. You can do it like that with product rule, or if you notice, because ln of x and ln of x is the same expression, you can rewrite ln of x times ln of x as ln of x to the power of 2. This is the definition of power. ln of x multiplied by itself, it becomes ln of x to the 2. And in this form, you don't need to do any product rule. If you continue in this method to find the derivative of ln of x to the 2, derivative is 2, bring the power down to the front, because note that power now is a constant. Bring the power down to the front and subtract the power by 1. 2 minus 1 becomes 1. And don't forget to find the derivative of inside. Derivative of ln of x is 1 over x. So this is one way to find the derivative of ln of x times ln of x. The other method that you can find the derivative of this expression is to use product rule. If you use product rule for this expression, derivative of ln of x is 1 over x times second expression plus, write the first expression, multiply by derivative of the second expression, which is again 1 over x. 1 over x ln of x plus 1 over x ln of x, these two expressions are the same. It equals to 2 over x ln of x. Note that any expression plus itself will be equal to 2 times that expression. A plus a, for example, equals 2a. Any expression plus itself equals 2 times that expression. So 1 over x ln of x plus 1 over x ln of x equals 2 over x ln of x. Note that this answer is exactly this answer. So it doesn't matter which method you want to use. The answer will be, of course, the same. The last step for finding the derivative of this function is to multiply both sides of this equation by y to get rid of this y in denominator. Y prime will be equal to y times 2 over x ln of x. And what was y? Y was original function. So y prime can be rewritten as x to the ln of x. Y is x to the ln of x, original function, times 2 over x ln of x. Now, to find the value of y prime, derivative of this function, at point E, we plug in E for every x that appeared in our derivative. So y prime at E will be equal to E to the ln of E times 2 over E ln of E. For every x that we had in our expression, we plug in E. Because we know that ln of E equals 1, we can rewrite this expression in the following form. E to the ln of E is 1, so E to the 1 or E times 2 over E times ln of E. Ln of E again is 1, 2 over E times 1 will be 2 over E. So we have E times 2 over E. E from denominator and E from numerator can be cancelled, and our answer will be 2. So derivative of this function at point E equals 2.